Assalamualaikum and salam sejahtera. This our member names. The first one is me, Daniel Aizan bin Azmi, followed by Ahmad Haziq bin Saiful Rahman, Muhammad Rafizul Irwan bin Muhammad Rafi, and the last one Muhammad Aidil Muiz bin Mat Izhar. The problem: a steel joint in a crane is held by two cables, one pulling at 14 Newton and the other at 15 Newton. Determine the resultant force acting at the joint and its direction to ensure the structure is safe. Okay, this is the question and the solution. We need to find the resultant force. The first one, we need to know the force as y-axis and x-axis. We need to find the total force as x-axis. 15 cos 30 degree plus 14 cos 180 degrees, and the answer is 23.3013 Newton. We need to find the force at y-axis. 15 sin 30 degrees plus 40 sin 120 degrees, and the answer is 59.6410 Newton. Then we need to find resultant force. Use this formula. And the answer is 64.0312 Newton. And then we need to find the angle. Use this formula. And the answer is 68.66 degrees. The resultant force at 68.66 axis above positive x-axis.
Hello guys, my name is Ahmad Razik and I will continue the discussion of vectors. The product is a two vector that can be used to determine work done when forces causes on an object to move. Let's do some example to understand more about the product. From the diagram, we can draw a free body diagram. So we can know that the x-axis is equal to I and y-axis is equal to J from the free body with the force of 15 Newton meter and 30 degree angle. And make this equation, which is 50 times cos 30 degree I plus sin 30 degree J. And other than that, we also can and then we multiply the 50 equal into the bracket cos 30 and sin 30, and we get 43.3013 I plus 25 J. Other than that, we also can make an equation using the distance, which is equal to 10 I plus 0 J, as we know that our work done is equal to force times distance. We just multiply the both equation, 43.3013 I plus 25J with 10 I plus 0J, and we get and we multiply it and we get 433.013 joule. That's all from me. Thank you.
Alright. Hello everyone. So I am Muhammad Rafizul Irwan bin Rafi. I will continue the presentation or the slide. As we know, cross product is one of the method from vector, and from this description say that cross product is a vector operation used to find new vectors that represent the rotational effect produced by two vectors. So at least we need two vectors. And what does cross product present? And as you can see here, the rotational of the wrench and nut, you can see there's a rotation. From the what does cross product present is a tendency of a force to cause a rotation, and the strength of rotational effect, that is called torque, and the direction of rotations. The direction of rotation can be present as a positive or negative. Let's go to the example. So the question asks to determine the moment produced by the force F, which tends to rotate the rods about the AB axis. As you can see, from A to the B, there's a two axes, X and Y. It's a between. So you can bring out the equation 0.4i plus 0.2j, and from A to the top of the road you can see that's a 0.3 meter, and from there to the C is like 0.6 meter, and you can see that there's a force at the C point, 300 Newton to the below of the road. So let's go to the solution. So we need to find first unit vector defines the direction of the AB axis of the road. First find the unit vector UAB equal to RB over RB. So it's not about it's not same, but it's same, I think. So 0.4i plus 0.2j over square root of 0.4 square plus 0.2 square, and you will get 0.8944i plus 0.4472j. Then next, you need to find the r, the distance. As you can see, there's a path between the axis to the force. For simplicity, choose RAD. So you choose from the A to the D. As you can see, from A to the D, there's the points is 0.6 I meter, and for the force it's a negative 300 kN because it goes to the negative direction. And next, you need to substitute this vector using equation of m, there's a moment or torque, AB equal to UAB, the unit vector, and then times the RD cross product F. So you need to find the cross product first. You need to find the result, the 80.5 meter, and then next you will get inner Cartesian vector. So what you need to do is times with the UAB. The answer we will get in the Cartesian vector is 72.0i plus 36.0j Newton meter.
So thanks to all of my friends for the good explanation. So my name is Muhammad Aidil Muiz bin Mat Izhar. So let's move to the function of vector in engineering. And the resultant vector represents the combined effect of multiple forces acting on a structure. So it helps engineer to analyze stress and internal forces distribution in structure such as beam, truss and frames. So by knowing the resultant force, engineers can ensure joints and materials can safely withstand applied loads. And lastly, it also assists in selecting proper joint design and reinforcement to improve the safety and durability. Second is dot product. The dot product measure how much one vector acts in the direction of another. In mechanics, only the force component parallel to displacement does work. Vertical force does not work because no vertical displacement. This concept is essential for calculating work, energy transfer, efficiency and power in mechanical system. And lastly is cross product. Cross product produce a vector that is perpendicular to the plane formed by two vectors. It is used to determine normal vector, which are important in surface analysis and 3D engineering problems. It also helps to identify the direction of rotation using the right hand rule, and it commonly used to calculate turning effects such as torque and moment in mechanical and structural engineering. That's all from us. Thank you.